Everybody. Welcome to Code is Chaos. Sonya, over to you.
Thanks, Alex. Hi, everyone, and welcome to The Code is Chaos, No One is Immune. So I'm Sonya, I work dark hoodies, and I listen to synthwave music, so I am a legit security engineer. So I wanted to start with a definition of what is cybersecurity and why is it important. So cybersecurity is the techniques of protecting computers, networks, programs, and data from unauthorized access or attacks that are aimed for exploitation. And I wanted to showcase a couple of examples of cyber attacks. So let's start with that one. You might be familiar with that page because it might happen sometimes that GitHub have that 500 status codes error where their server is actually down. So we've seen an instance in 2016 where there was a series of DDoS attacks that were launched against DNS servers, and we had services like GitHub, as I showed, PayPal, Spotify, and Twitter, and many others that went down. So first of all, what is a DDoS attack? So usually you would have the attacker that will launch and try to control some devices, and they will use those bots to actually target victim servers and will try to exhaust all the resources that a website have, and usually you have the website down, which is quite scary, actually. And how is it possible? So usually you can use website like Shodan. Shodan is defined as a search engine for internet-connected devices. And for the purpose of this presentation, I've done an example where I just type webcam, as you can see on the search input. And those are all the webcams that are publicly connected and available on the internet. The good thing with Shodan, it will give you also a little bit more information around services, organization, operating systems, and other information that you would have, which is actually quite scary also. Just out of curiosity, I clicked on one, and obviously for the purpose of this talk, I redacted the IP, but this is basically an outside CCTV that you could find at Canada, which is really scary. Another cyber attack is ransomware. So this one is from the WannaCry. So basically, the WannaCry attack happened 3-4 years ago, where there's a consortium of hackers called shadow brokers that actually stole code from the NSA and made it publicly on Twitter threads and feeds. And it was based on, so one of them was based on Microsoft's vulnerability. And when you were using that vulnerability, you could also level up with this ransomware, which is called WannaCry ransomware. So basically, you would see the Bitcoin, or because they want to have some currency or money from that to make it decrypt your data. So basically, what is a ransomware attack? So at first, you'd have the attacker, they would send a phishing email, and then you as a user would open that email and click on the link, which you shouldn't if you don't know the sender. But on the background, you'll have a malware that will impact and execute. And also you have those control and command and control communication that would download a public key. And for you to have your data decrypted, because the ransomware will encrypt your data, you'll have to pay Bitcoin. This is why there is a small section with the Bitcoin wallets. And once the attacker receives the Bitcoin wallet, the Bitcoin amount, they'll provide a private key where you could actually encrypt your data. Usually, an attacker would go through what we call the cyber kill chain. Not all the stages are required for that, but usually an attacker would spend some time on the recon phase, where they look at some email addresses, or if they have any publicly available information from the company or from the victim that they want to target. They'll spend some time to create what we call weaponize and try to create a payloads. Then they will obviously deliver. So in that case, it was a phishing through a phishing email. And then once they have this entry point, they will exploit. So using the weaponized payload that they've created, which would install on the background, and then they'll try to what we say command and control. So try to pivot if they're within the network, so they can jump on another device or machine. And then it depends if they want to exfiltrate the data or do other things once they have control on the machine. This is just to show you the impact of the WannaCry ransomware, which actually impacted more than 150 countries. Another example of cyber attack is what we call sextortion. So this is also based on phishing email, but the little bit blurred on the top that you could see is actually the password. So usually the attacker will send you an email saying, I know your password, and I know you've been doing naughty things in front of while you were watching adults' websites. So basically, because I've installed a malware and then I've used your webcam to record what you've been doing. And basically, it's to blackmail you and sending that potentially video that they've recorded to your family or your employer. And again, the same section with the Bitcoin address. Obviously, this is a scam. They've just gathered all these passwords and account through from previous data breaches. A good advice that I would say if you want to see in which data breaches you've been involved would be to go on a website like Have I Been Pwned? So instead of, in place of I love Athena HACKDEN 2021, you should put your email address. And also recently, Troy Hunt, who is the researcher behind that website, added the phone number. This is following the Facebook breach that happened recently. So using your email or your phone number, you could see if you've been part of a data breach. And if you've been part of a data breach, I would strongly recommend to rotate all of your password and not use the same password for every website. So how data breaches occur? So usually you would have an attacker, they'll look for weaknesses on your websites that they can actually exploit it through two ways. Through social engineering, so they'll probably do, like I say, phishing or vishing. They'll also look at some weaknesses within the infrastructure of your website, so using SQL injection or any exploitation that they could use through vulnerabilities. Once they've managed to have a footprint on your applications, they will exfiltrate the data, because for them data is money, because they can resell that data with your personal information. And this is how usually data breach occur. This is just to give you an example of all the companies that suffer from previous data breaches. And you can see actually all the industries have been touched on that. This is another graph also to showcase some of the world's biggest data breaches and hacks that have been from 2012 to 2020. So now we've seen the cyber attacks overall, let's funnel down to the web application attack and how only 22 lines of codes almost had 400,000 victims. And that company was British Airways. This happened 3 years ago, on September 6th, they've announced that they've suffered from a data breach. So they noted that almost 400,000 customers could have been affected and that they have stolen information, including their personal and payments information. The payments were through their main websites were affected. The payments through their mobile applications, so Android and iOS, were also affected. And the attack was between August 21st and September 5th, 2018, so only over 2 weeks. This is the time period of the attack. So what happened in that case? So we know that the customer data was stolen directly from the payment forms. And usually when you're a security researcher, we look for patterns. And we've seen that the same behavior happened with the Ticketmaster UK. When they reported a breach, it was exactly the same pattern. And we knew that MageCard was the main suspect. So you would ask, Mage who? So MageCard is actually a consortium of malicious hacker groups that target online shopping cart systems to steal payment card information. This is known as a supply chain attack. So what was the entry point for the British Airways vulnerability? It was actually a JavaScript library called Modernizer, and more specifically, the version 2.6.2. So what happened if we have a look at the codes, we could see at the bottom the 22 lines of code that they've added. And basically, the change is performed at the bottom of the script because that technique is for the attackers. Just they don't tamper with the they don't modify the JavaScript files because they don't want to break the functionality. They just stick the code at the bottom of the script. Also, one thing to note is that the server sends a last modified header, which indicates the last time the piece of static content was modified. So if we look at that, the first modernizer, the last version was from 2012, but if we look at the tempered one, we could see it was dated from 21st August of 2018. So we knew that that file was tempered. This is the piece of code. So you can see only 22 lines that actually help the attackers to perform the attack. If you're not familiar and you don't get what's going on here, so basically when a user on the payment page hits the button to submit their payments, the information from that page is extracted along with their name, and then it's sent to the attacker server that we could see at that endpoint URL baways.com. And this is part of the recon phase that I mentioned during the cyber kill chain. They've actually spent some time during the recon phase to actually register that endpoint so they can collect all the information. In that case, it was baways.com. So what about the apps? Because we've been talking about the websites. So we know a portion of the application is native. So should be using Kotlin or Java for Android, or Swift or Objective-C for iOS. But the majority of its functionality loads from web pages, from the official BA websites. And we know so we could use those functions to directly inject JavaScript within the mobile application, which is WebView for the Android version and WK WebView for the iOS version. And that page was the one that was compromised. In that case, if we're looking at the source code, we're back to the same issue because the same CSS and the same JavaScript components that they've been using for the websites. And obviously, they were using also the same library, Modernizer. So what happened, BA was fine under GDPR for data breach. So another example of what could go wrong, and specifically with GitHub, is around credentials, tokens, and environment variables. So we all know that GitHub is housing thousands of publicly accessible keys, tokens, and search results. You can also do the tests. You can go on GitHub and type API keys, credentials, password. Well, I have a lot of results. Some of them are legit, so there might be information on a README file, or they just have some reference from the API keys, but other are actually real API keys or credentials that you could use. And you can actually find keys for services, including all of them, like Google, Twitter, AWS, Facebook, Twilio, Stripe, and many, many other services. Just to give you an example of some of the keys that have been pushed on GitHub on public repos. So you could see that the bit in red is because the developer probably realized that it pushed the keys on GitHub and they tried to delete it. But too bad, because GitHub is version control, so they actually keep track on it. Yeah, and you can see the last one. They probably realized that they've pushed the live key instead of the testing keys, and they're trying to remove it. You could see the red and the green one, but it's too late. A real case example is Uber. They also, one of the developer pushed a key on their public repo, and it leads to obviously attackers getting that public key and have access to internal Uber database that gave them access to more than 50,000 drivers' information. So what is web application security and SSDLC? So web application security is a branch of information security that deals specifically with security of websites, web application, and web services. And within the web app security, you could also find a section around secure software development lifecycle that will actually process and ensure that the security activities are performed at every stage. So that could cover penetration testing, code review, threat modeling sessions, architecture analysis, and many, many more activities. This will have as an effect that the security is a continuous concern, and there's an awareness of security consideration by all the stakeholders and not only the engineers. And also a good thing is that when you have early detection of flows, there's a cost reduction, because if you find those flows at the end of the production, you'll actually have to spend more time to fix those. So how can I protect my websites? Which is quite a broad question. I'll try to present you a couple of security features and a couple of security tools to help on that. and specifically linked with the British Airways example that I've mentioned, a good one that could potentially protect you from that is a content security policy. A content security policy is an HTTP response header that would restrict how resources such as JavaScript, CSS, and other assets that are using on your website are loaded by the browser. And this will also help you mitigate injection attacks. So how does it work usually? When you have that whitelist, so for example, you have the example.com, if the URL is different, it will be blocked because of the CSP that you've set up. There's a really good website called Content Security Policy, which acts as a reference guide if you want to learn more. They go through all the browser and the supports for them. They also give you example of the different directives that you could use, because obviously websites have a lot of complexity regarding of the assets that are using. So if you're using script images, fonts, media frame, so you have all of those that can be covered within when you constitute your content security policy. There's also all the value that you can set to next to those directives as well. And they will give you some example, some starter templates if you don't know where to start, which is quite good. One thing to note is I know that some developers might be quite reluctant to implement a CSP because there are some breaking changes on production, obviously. What I would recommend is to start on this testing environments and also having an endpoint where you could actually collect all of those errors that you get when you try to fine-tune your CSP. A good endpoint to collect is report URI. So on the website, it will collect all of those errors and will help you fine-tune your CSP. And then when you have confidence, you can actually push it to your production servers. Another good one is server source integrity that goes with pair with the CSP. So the SRI enable browser to verify if the resource that they're fetching are delivered without unexpected manipulation. And it's based on cryptographic hash. So basically, when you have the client with will fetch, let's say, a CSS file, and the integrity hash is set, for example, at that one that you could see the lorem 1C6B. If the attacker is trying to load and push another style file, but with a different hash, it will be loaded by the clients. There's an example with Bootstrap. They do have the integrity hash on it, just to showcase that, yeah, it exists. And if you don't have the SRI hash, but you would like to generate it, you can go on a website like the SRI hash generator. You just add your CDN endpoint, and it will create that hash. Also, as you could see, if you look at the website caniuse.com, there's a fair amount of browsers that are supporting those CSP and server source integrity. Another good example on how it could actually protect websites, also that case that happened 2-3 years ago and that impacted a lot of governmental websites and the ICO. If you look at the yellow boxes, you could see this coinhive.com, which is basically a crypto miner. So what happened is that more than 4,000 websites have been victim from that. And if they had the CSP and SRI, it could actually mitigate that attack. So it wasn't the website themselves that has been compromised. It was actually a script that they were using that had dependency on. And that script was coming from BrowserLoud. So BrowserLoud, they're developing accessibility tools, which is great to have on the website. But as you can see, there's no SRI, there's no integrity hash on that. So what happened is that script, ba.js, has been compromised. You could see this at the top. There's a little gibberish that you can't really understand. That was the bits where the crypto miner was inserted. And if we deobfuscate the piece of code, we can see that actually that code will start the crypto miner and use your CPUs. Obviously, will slow down your machine and the websites. So that was a quick overview of security features. Let's move on to security tools. So we could have a look at the tools that the GitHub Marketplace is offering. And I would actually strongly recommend for those who don't know that GitHub is a marketplace and they provide applications and GitHub Actions, which are all free for public repos. And if you have samples projects, or even if you're prepping for a tech task for companies. That's a good way if you're hosting your code on as public repos on GitHub. And you could see they're covering different categories, including code quality, code review, security, CI/CD pipeline, and all of those. So let's have a look at the security section. As you can see, there's a lot of application that they provide for free on that. If you're interested by one, you can just click on them. And usually, if you scroll down to the pricing and setup, all of these, most of the applications are free for public repos and quite easy to set up. So let's start with Dependency Graph and DEPENDABOT, which are native products from GitHub. So the dependency graph is available for every public repo that define dependencies in a supported language using a supported file format. So basically, if you're using Yarn, you'll have a Yarn log. If you're using Python, you will have requirements.txt. And having those files, the dependency graph will scan those files and let you know if there's any vulnerable packages. This is good to give you visibility. The good thing is this is a recent change from GitHub. If you go to settings and security analysis, you can actually turn this feature on over all the repos that you have and also enable it for all the new private repos that you're going to create for both the dependency graph and the DEPENDABOT. So it's good to have visibility, but it's even better if you can act on the vulnerabilities. And that's when you can use the DEPENDABOT. So basically, DEPENDABOT will raise automatic pull requests. You can also install it so on the marketplace or just enabling it through your settings. And basically, it will raise a pull request, letting you know which version you have to upgrade your dependencies. If you're not confident by upgrading those dependencies, the good thing with DEPENDABOT is they have a compatibility score. And basically what they do is they will look at the different open source project using also that package. And if it doesn't break their CI/CD pipeline, they will up that score. There's also an integration on Slack using the GitHub one, so you can also follow that. If you want to configure the DEPENDABOT, you can do so using a YAML file, config.yaml file, and you can see there's a lot of features and can be really granular on the flags that you want to add on that. Also, quick tip, if you only want to see your DEPENDABOT findings on GitHub, I would recommend to go to the little bell at the top right corner, and you can actually create your filters. So for DEPENDABOT, I've created one called DEPENDABOT with a little bug emoji. But more importantly, the filter used is issue or pull requests. And when you've done this, you will only see DEPENDABOT one because the dependency graph one can be a little bit daunting. There might be a lot of those. Another great tool doing also vulnerability management, dependencies scanning is Snyk. So again, Snyk, you can find it on the GitHub Marketplace. Also, it's free for public repos and open source projects. They do have a platform where you could follow all of the dependencies that you have within a project that will give you the visibility. And they also give you a bit more insights when there's a specific vulnerability if you want to have more information. If you have the paid version, you can create also Jira issue. But the version for the open source one is totally fine as well. There's also, if you're using Slack, a neat integration as well from Snyk. And also, if you want to have a look at GitHub Actions, and if you don't know where to start, I would recommend to go to the Action tab that you have on your repository. They have some workflow template just to get you started. If you're more interested with security, you can go to the Security tab, and they will help you with what they have, CodeQL, which is basically their static content scan. The only recommendation on here is there's a language step at the end of this file. I'll recommend to specify the language that you're using. Obviously, that will help because otherwise you'll have a fail in the build. And then you're good to go. You don't have anything to change on that, and it will trigger that scan every time you're pushing code when you're merging pull requests. It'll do that static scan analysis on your code base. Another good one is Sonar Clouds, which is an external platform, online platform. And basically with SonarCloud also, you'll have to you could use GitHub Action. The only thing that you will record is a SonarCube token, so that you could get when you sign up through SonarCloud. And how you would host that secret, because usually you could host it if you're using continuous integration, you could host it on Jenkins, you can host it on Circle CI. The good thing here, you can also host it on GitHub. I would recommend to host it at an organization level. If you go to settings and then to secrets, you can create your secrets, and then you can select the repo where you want it to affect, and it will cascade those secrets. And all of the action usually are, you can find them at the .github/workflows. You'll have all of your workflows, GitHub actions within this folder. So how does it work on GitHub? Because you have installed all of those tools, security tools, code quality, code review tools. So usually when the developer will raise pull requests, it will trigger that pipeline. So if you scroll down your pull request, you'll see at the end a list of all of the checks that you've added, depending on the number of tools, obviously, that you've added to your pipeline. Some of the tools might have native widgets. So the one that I've mentioned earlier around SonarCloud, they do have a widget that will be implemented within your pull request. So you don't need to go on the platform. You can actually directly see from the pull requests. And this might be your source of truth for the developer. They'll see everything within their pull requests. So it looks like this. When you scroll completely at the bottom of your pull request, you will have all of those steps. What you can do is, if you protect your master branch, you can actually set them as required. So depending, you can create threshold, you can make them required. It will depend on the discipline that you have within your team. Also, depending if it's natively integrated or not, you can go to the checks tab on your pull requests and see also that information. So again, for SonarCloud, you don't need to go on the platform. Everything is on your pull requests. How to get value from chat ops. So chat ops basically is depending on the tools that you're using. In that case, it's Slack. So all the integration that you can do with those tools. So for example, in that case, you will have Circle CI for your continuous integration, Netlify for hosting, guardrails. This is for compliance and security, just to scan if there's any tokens that you've pushed to your public repo, Rollbar for live monitoring. So depending on the pipeline of tools that you have, it's good to have integration within Slack or any of the tools that you're using for communication, because your developers will be on that platform and they're the one that will fix if there's any problems. So it's actually a good thing to have those integration in one place. And this is just to give you an example with the GitHub one. So if you have integrated all those tools in the pipeline, you can see in real time color changing. If there's anything wrong, then you can go and investigate on the pull requests. Also, just wanted to mention the elephant of the room, COVID-19 impacts on cybersecurity. So cybersecurity projects often languish due to budget constraints, scarce resources, or because they're just lower priority in the long list of things that needs to be done. But COVID-19 pandemic has pushed many of these initiatives to the forefront where they're gaining traction, which is good for us. This is just to give an example of some numbers from last year. You could see that the attackers took advantage of the pandemic to craft some of their payloads and malicious URLs, malware, phishing attempts around COVID-19. This is an example of an email impersonating the World Health Organization to ask for a donation, for example. This is another phishing attempt just to sell some tests for COVID-19. So there's a lot of trends around that where attackers try to surf on the pandemic to perform those attacks. So things to keep in mind as a company during the pandemic. It's always good to lock down the supply chain. We've seen it with British Airways. It's always good to have a look at the dependencies that you're using. There's a lot of tools, as I mentioned, DEPENDABOT, SNCC, and others that you could use for that. Identity and access management. Obviously, access control is an important one. If you're a maintainer of open source project, you can actually enable 2FA. You can create groups of user and give certain access to certain repos. You don't need to give a full access to all the repos that you have within our organization. Patch management is also a link to supply chains. Try to keep your dependencies up to date to the latest. Security awareness and cyber hygiene. Also, there's an important piece around education and educating the developers around those, and also to give real life case and real examples on this is what can happen. Actually, this is actually what happened to different companies. Threat monitoring as well, IoT security. We've seen it with Showdown. It's easy to have access to all of those IoTs that are available publicly on the internet. Zero trust networking, and also an important one, which is social media compliance. I want to stress enough importance on being really worried on what you're actually posting online, because it could give some intel to the attackers. Should it be a Zoom meeting ID, like in the case we remember what happened last year in the UK. But also, you might have seen all those posts on LinkedIn where companies, they like to share stuff around people working from home, and they like to share their screen, so you can see like it depends, like bookmarks or the icons at the bottom of your screen. It can give intels on the application that a company might be using. So just be wary on what you're sharing on social media. So if I haven't scared you, and if you want to learn more about security, that's great. So I would recommend as a good starting point the OWASP Foundation. So OWASP stands for Open Web Application Security Project. It's a nonprofit organization with a mix of security researchers and developers. They do create tools, resources. They also have meetups all around the world. So you might know OWASP with the OWASP Top 10. I would strongly recommend to go on the website and have a look at all the other amazing projects that they're doing. The good thing is it's all free. So a lot of free goodies around mobile application, API, security, IoT security, how you would test an application, and all of those. There's a lot of really good guidelines of different topics. A few more on the hands-on labs type. Good news, there's a lot of resources for that. If you're a beginner, I would strongly recommend to start with Try Hack Me, because they do have a mix between walkthrough and CTF, because usually CTF can be a little bit daunting. You don't know where to start. So Try Hack Me have those step-by-step walkthrough to help you. When you gain a little bit more confidence, you can move on to Hack the Box, where you have machines that you need to pawn. So you'll have to find two types of flags. So the guest flag and the admin flag, so which means that you need to do some privilege escalation. It's quite tricky, but it's interesting. They also launched recently the Hack the Box Academy. So they have small modules around a security topic. Also, it's quite good. And those platforms will help you on setting up your security lab. So depending if you're using VirtualBox, you can set up your Kali Linux operation system. And you will learn how to use, for example, tools like Nmap to scan ports, which ports are open, Metasploits, where you have a collection of payloads to attack during those CTF. John the Reaper, this is to crack passwords, and also you'll learn more around Linux, around Windows, and all of those. Another one also from OWASP is the OWASP Juice Shop. This one is a Node.js application, a vulnerable one, so you can also have a go and play and try to find the vulnerabilities around that. Also a good one, Web Security Academy from Portswigger. They're the one who created Burp, which is a proxy tool to help you test a website. They have learning materials and labs. You can sign also to save your progress. They have a lot of interesting labs and material. When you once you gain confidence and you actually want to earn money from from ethical hacking, you can go on platforms like Backrot and HackerOne. So basically, they will allocate you to programs, to companies, and you can actually test those if you find vulnerabilities in those companies. And if you're lucky and you find one, you can actually get paid for that. And both of them, Backrot and HackerOne, have their own other universities and academies also, which is great. Finally, if you're in a company and you are interested in moving to security, but you're not too sure, you can actually ping your security team and check if they have a security champion path. So basically, security champion will act as the bridge between the security team and the developer team. And you can have a sense and gist of what it is to work in security, which could be a good opportunity for you. Also, I wrote a piece on Medium called Keep Calm and Become a Security Engineer, where I gather more resources if you have an interest in security. This would be around podcasts, YouTube channels, and all of those. I've tried to gather some of it on it. And also, I'm driving an initiative called Epic Women in Cyber. So if you want to read some interesting pieces of around women who are working in the industry and get inspired by them, yeah, I would also recommend to have a look at that. So some of the key takeaways, as we've seen with British Airways, open source can be vector for large-scale cyber attacks. Open source is great, don't get me wrong, but sometimes if it's not maintained properly and if you don't take care about the dependencies, it can actually be a vector. I would also recommend to leverage the application available on the GitHub Marketplace. I showed you it's also easy to set up, just to set up a quick small pipeline, and also harden your GitHub security for your collaborators. So as I said, enable 2FA on GitHub if you're a maintainer of open source projects, and also try to create some small teams and allocate users within those teams and give specific access to specific repositories when doing OSS. Overall, I'll say experiments. Yeah, that's great. And also, please don't push your keys on GitHub. And yeah, I'll just finish with my motto: get secure, be secure, and stay secure. Thank you.
Thank you very much, Sonya. That was amazing. If you've got any questions, do let us know in the comments or on Discord afterwards. I'm sure you haven't scared everyone off, and for those that haven't been scared off, yeah, some great takeaways, some great sources. Definitely go and follow Sonya on LinkedIn and Twitter. The Epic Women in Cyber stuff is amazing and a great cause. So yeah, and who knows, maybe one day in the future, some people that are listening to this now will be one of those epic women in cyber. So yeah, a big thank you to you, Sonya, for giving up your time. And yeah, I think that get secure, be secure, and stay secure is a good note to end on.
Thank you for having me for this event.
No problem. Thank you. Bye bye, everyone.
Bye.
Awesome. Thank you very much.